So the graphical approach to solve this question would be drawing a velocity time graph for the motion. Now, why are we specifically drawing the velocity time graph? Because area under the velocity time graph would give you displacement, right? So area under the time graph represents displacement. We will first apply this velocity time graph to the segment of motion from A to B. Then we'll backtrack it and then we'll apply that to O to A. Okay. So the body is dropped from O, it reaches A, then it travels up to B. We will first draw the velocity time graph, then we'll find the actual curve. We will find the area under this curve from A to B, which will be like this, A to B, and then we will backtrack that data to O, and then area under O to A will give you the displacement under along the motion O to A, which is what we've been asked to find out, the distance from O to A. Okay. So let us first understand the setup of the graph. Now, what do we mean by setup? The x-axis, the y-axis. What are the variables used? How do we arrive at the equation? Since it is under free fall from rest, the acceleration is constant, which is g is equal to plus 10 meter per second square, which means the velocity would increase linearly with time. Therefore, the VT graph is a straight line. Now, you might ask why? Because V is equal to U plus AT. What is the value of U? Since it is dropped, the value of U is equal to 0. So this becomes 0 plus A is equal to G. So this becomes 0 plus GT, which is V is equal to 10T. So when the body is dropped from O till it reaches the ground, the velocity would follow the velocity time relationship as V is equal to 10T. Now, what is V is equal to 10T? Is that familiar otherwise? Yes, because it is Y is equal to mx plus c. Or in other words, is V is equal to 10T plus 0. Right? So we have a straight line with slope 10 and velocity along the y-axis and time along the x-axis. Okay? Basis of coordinate geometry. Now, if we substitute t is equal to 0, we get v of t is equal to 0, which means it is just dropped. At t is equal to 1, 10 times 1, velocity is 10 meter per second. T is equal to 2, the corresponding velocity is 20 meter per second. 3 is 30, 4 is 48, 5 is 50, so on and so forth. But we don't know the values of V and VB. We only know that VO is equal to 0. Of course, we have found out that VA is equal to 30, but we're talking about only the approach using graphs, right? Now, time to reach A is dA, time to reach B is dA plus 2. Why? Because it is given in the question that it takes 2 seconds to travel from O to A and then to B. So A to B, the travel is for 2 seconds. Velocity is VA plus 20. We'll come to that. Now, coming to the graph here. So first let us plot a graph where y is velocity and x is time. 1 second, 2 seconds, 3 seconds, and the corresponding velocities are given here. Now, using this table, can we plot the graph now? So when we plot it, we have 0 corresponding to 0, this point over here, the origin, right? The origin. 1 corresponding to 10, 1 corresponding to 10, 2 to 20, 3 to 30, 4 to 40, which means we get a straight line like this, right? So we have the velocity time graph now. Velocity along y-axis, time along x-axis, and a straight line. passing through the origin. Now, 3 points along this motion are really important to us, which is point O, point A, and point B. The variables in these 3 points are also relevant. At time, the object is at point O at time t is equal to 0. It is at point A at time t is equal to TA, and it is at B at time TB, which actually is TA plus 2. Why? Because it is given in the question that the object travels from A to B in 2 seconds. Speed at the point O is equal to 0. Why? Because it is dropped. Now, this is where I suggesting you, in fact, I requesting you to make notes become really important, because when you write notes here along with me, you will write here speed is 0. Why? Because it is dropped. This is TA plus 2. Why? Because it is given in the question that t from A to B is 2 seconds. Right? So please write this along with me. The corresponding velocity at A is VA. At B is VB plus 20. Distance the object has just started the motion is 0. At A, the body has traveled OA, which is SA. At B, the body has traveled OB, which is SA plus AT. Why? Again, because it is given in the question that A to B is 80 meters. So you'll write this along with me. Distance from A to B is 80 meter, according to the question. And the body is not yet reached the ground. Okay. Now, while we consider the motion along OA, so this is the object traveling, the corresponding position OA. You can write down the velocity maybe from V0 is equal to 0 or VO is equal to 0. I should have chosen A, B, and C. Would have made more sense here. My bad. Okay. So apply equations of motion. We have V is equal to U plus AT. Now this equation is applied to the motion along the path O, motion along the path OB. Oh, sorry, motion along the path AB, which means this is the motion that we are trying to consider, motion along the path AB. What is V? The final velocity. What is the final velocity? Velocity at the final position, which is V, therefore VB. What is U? Is the initial velocity. What is initial velocity? It is the velocity corresponding to the initial point, which is A. What is A? The body is moving. The body is moving downwards. Direction of initial velocity is downwards, and therefore acceleration is equal to, exactly, would be equal to plus G, plus 10. What is T? Time taken to travel from A to B, which according to the question is 2 seconds. Therefore, VB is equal to VA plus 20. Now, why do we need this expression VB is equal to VA plus 20? We'll come back to that in a while. So yes, this is not again purely based on, I think I said sometime before that this is purely based on graphical method. No, my bad. This is not purely based on graphical method. We are dependent on equations of motion, plus there is something else, which could be either equations of motion, solution 1, which could be mechanical energy conservation, solution 2, which could be force work energy theorem, solution 3, which could be graph, the one we are visiting now. Okay. Now let's see, why do we need this? So we know that for the motion along the path AB, velocity changes from VA to VB, where VB is actually 20 more than VA. VB is 20 more than VA. time changes from TA to TB, where TB is TA plus 2. TA plus 2. But where is this AB present? VA can be 50, VB could be 70 then. Corresponding time would be 5 and 7. But it could also be the case that it's 2 here, VA, and 4 seconds is VB, and the corresponding VB are 20 and 40. That also satisfies the equation. So how do we find the accurate value of VA and VB? So to understand the graphical approach here, for the motion along AB, area under the VT graph, which is area under the graph, this green graph here, ABCD, area under the graph AB, which is this region here, ABCD. What is area under the VT graph? Area under the VT graph is displacement. Therefore, area under this graph AB would be displacement from time corresponding to TA to TB. Does that make sense? Let's see that one more time. So area under this graph, which is the sum of all these values here, which is the sum of all these, oops, my bad. Just the sum of all these small areas here. If you add all these, what do you get? What we get is area under AB, which is displacement AB. And this displacement AB, which is the area of trapezium ABCD, is known to us. Why? Because it is given in the question that the displacement AB is equal to 80 meters. What is area of trapezium ABCD? It is half times AD plus BC, which is BC, times CD, which is CD. Okay. Now, if you want to make a proper note of this, I have included this in a separate format here. So if we were to find out displacement from A to B in the graph, it is corresponding to the time TA to T plus 2 is the area of the trapezium. And area of the trapezium is given by half into VA plus VB into 2. But what is VB? We found out using equations of motion that VB could be written as VA plus 20. And therefore, displacement AB is 2VA plus 20. The AB is equal to 80, and therefore VA is equal to 30 meter per second. Something that we've been doing for the past 3 questions, or 3 types of solutions, right? Now, once you understand VA from this, right? Once you understand VA from this, which is equal to 30, since VA is 30, 30 plus 20 will give you VB, and VB is equal to 50. Okay. So we have 30 here. What is 30? 30 on the graph, on the straight line graph here, corresponds to VA. 50 corresponds to VB. So this was the actual trapezium that we are talking about. Okay, hope that makes sense. So now we can shade 2 different regions here. Now I'll do that slowly so that you can tell me what this is about. What is this shaded region? This is area under the graph. Yes. Which graph is this? This is the velocity time graph. So what are the corresponding positions? Are from A to B. So the shaded region in yellow here represents area under the AB curve in VT graph, which is displacement AB. Okay. In which case, what would be this triangle here? What would be the sum of these areas, these small areas? My bad, sorry. What would be the sum of these? So this area here represents area under the VT graph. Why? Because we have velocity on y-axis and we have time on x-axis. So area under the VT graph is the area from time t is equal to 0 seconds to time t is equal to 3 seconds, which gives us the corresponding displacement from O to A. Now, what is displacement from O to A? It would be area under the graph, which is half times the base. How long is the base? The base is 3. Half times 3. And what is the height? The height is this much, which is 30. So half times 3 times 30, which is half times 90, which is equal to 45. And if OA is equal to 45, what is that we've been asked to find out? The distance of upper point A from starting point is 45 meters. Okay. So yes, that was regarding the solution using graphs. Yes, now comes the most important point, which is something that all of us have been thinking of right when we did this question, is to validate our claim that the body is actually dropped by fixing that with the by joining that with the given data. S A to B in 80 meters is covered in t is equal to 2 seconds. Okay. Now, for a while, I'm going to take a break from this question. So, what I want to do is, I want you to, since that we have completed 3 to 4 different methods to solve the same question, I would request you to spend some time in actually finding out, is this assumption valid? Are we taking it in the right direction? Okay. In the meanwhile, I will take you through a different set of questions, and once we are done with that, we will come back to this question. Okay.